Measures of variability are the spread of values about the mean. These are smaller dispersion of scores arising from the comparison, often indicates more consistency and reliability. It consists of range, average deviation, variance, and standard deviation. Range is the difference between the largest and the smallest scores. This is the formula used. R is equal to H minus L, where R represents the range. H is the highest score and L is the lowest score. So let us take this given. Given the scores of the following grade 7 students, 43, 46, 40, 39, 45, 42, 47, 50, 49, 39. Find the range. So just simply write the formula. Then from our given, just identify the highest score. So in this case, it's 50. Then the lowest score is 39. So you replace it in our formula. Then subtract them. And that is 11. So this will be our range. Average deviation gives a better approximation compared to range. The formula used is AD is equal to summation of the absolute value of x minus mean all over n, where AD is the symbols used to represent average deviation, x is the individual score, x bar is the mean, and capital N is the number of scores. So we will be using the same data to solve for the average deviation. Before we can use the formula in average deviation, we need first to set up a table with 4 columns. In our first column, we're going to write the given data. So then at the end, you're going to add all the number of scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this capital letter N, which represents the number of scores, that is 10. Then to fill out the second data, that the second column, that is the mean. Recall that in solving for mean, we will just simply get the sum of all the scores divided by the number of scores. So these are the given. We will just add them, then divided by the number of scores, which is 10. So the sum of the numerator is 440 divided by 10, and that is 44, and that will be our mean. So we're going to write it in our second column. Now to get to fill out the third column, so we will just simply subtract whatever the x or the scores minus the mean. So for this row right here, we will just subtract 43 minus 44, and that is negative 1. In the second row, 46 minus 44, that is positive 2, and so on and so forth. Then after that, to fill out the fourth column, so we're going to get the absolute value of the third column. So when you say absolute value, the number, or that is the distance of the number to 0 in a number line. So when you say distance, it is always positive. Therefore, the absolute value of negative 1 is positive 1. Absolute value of a positive number, which is positive 2, is still a positive. So that is positive 2. So all the numbers here in this data are all positive. So negative 4, that is positive 4, positive 5, positive 1, positive 2, positive 3, positive 6, positive 5, and positive 5. Then lastly, we're going to sum them up because in the numerator of our formula, we're going to get its summation. So it means we're going to sum them up. And that is equal to 34. And this is our numerator. So we are now ready to use the formula. So we'll just simply replace the numerator with 34 and the denominator with 10. Then 34 divided by 10, that is 3.4, and this will be our average deviation. Next is the variance. It measures how far each number in the set is from the mean. This is the formula. Sigma squared is equal to summation of quantity x minus mean squared all over n, wherein sigma squared is the symbol that represents variance commonly, and x here represents the individual score. X mean is the x bar is the mean. Capital N is the number of scores. So we're going to use the same data to solve for the variance. We will be preparing the same table with the same symbols because notice that in solving for average deviation, the formula of average deviation and variance are almost similar except in the fourth column. So instead of getting the absolute value, we're going to square the third column so that we can get the fourth column. So it means there's no problem with the first, second, and third column. We'll just fill them out. Then, to square for the fourth column, so negative 1 squared, that is 1. 2 squared, that is 4. Negative 4 squared, that is 16. And so on and so forth. Then, find their sum because we need to get the summation of the fourth column. So if we're going to add them all, that is 146. And we are now ready to use the formula in finding the variance after preparing the table. So we'll just simply divide them, 146 divided by the n, which is 10, and that is 14.6. And this will be our variance. By the way, this symbol right here, which is sigma, this is another Greek letter. Okay, so and it is read as sigma. Last, the standard deviation. It provides some idea about the distribution of scores around the mean. So this is the symbol, or this is the formula used. SD is equal to square root of the summation of x minus, or quantity x minus mean squared all over n, wherein SD represents the standard deviation, x is the individual score, x bar is the mean, capital N is the number of scores. Notice that the radicand, or the number inside the radical sign, is actually the variance. So the difference between the formula of the variance and the standard deviation is, in standard deviation, we just added the radical sign to get the square root of the variance. So it means if our given is the same, we will be preparing also the same table with the same content. Alright? So after preparing this table, we are now ready to use the formula in finding the standard deviation. Alright? So our numerator here is the summation of quantity x minus mean squared, and that is 146. Then our n here, we will replace it with 10. Then 146 divided by 10, that is 14.6. Actually, this 14.6 was our variance a while ago. But since we are looking for the standard deviation, we need to get its square root. So the square root of 14.6, so using calculator, that is 3.82, and that will be our standard deviation.